Assalamualaikum and hello everyone. Self exercise 3. Calculate currents I1, I2 and I3 by using Kirchhoff's law. In this video, I would like to share with you how to solve this question using Kirchhoff's law.
Take a look here. In this question, those current I1, I2 and I3 has been labeled on the circuit, and also the loop direction have been determined so that we have followed this label and the loop direction while we are solving this question. Now that we solve it step by step, okay, so if you still remember, our solution step will be start from the first one is the form KCL equation from total I in equals to total I out. I in here is current I1 moving inside the node I1, so I out is I2, I1 plus I3, plus I3 equals to I2. So I1 and I3 is coming inside the node, and I2 is leaving the node. So I1 plus I3 equals to I2 will be the first equation. Okay. Now we go to the second step, form KVL equation. Form KVL. For Kirchhoff voltage law, as we have the loop direction here, and it has been labeled at loop 1 and loop 2. Okay, so to make ease for our solution, so loop 1 we will replace it with loop I1. So loop 1 become loop I1, where it is labeled on the left side of the circuit, and loop 2 becomes loop I3 here, because I3 is the label of the current on the right wing of the circuit. So for loop I1, the equation of KVL from total EMFs equals to total voltage drops. Okay, so loop I1 here, so we have two EMF, 10 volt and 15 volt. So for 10 volt, the direction of supply is same with the direction of loop, both in same direction, so we have positive 10. While for the 15 volt EMF, the supply at this direction and the loop is on the opposite direction. So because the opposite direction of loop and the actual position of supply, we should put here minus 15. And around the loop we have 100 ohm and 200 ohm resistor, so 100 plus 200 time with loop 1 is loop I1, so time with I1. And remember, 200 ohm is located at the middle center of the circuit, so it will be also be flown by loop 2, which is the loop I3. So we should have 200 I3 here, and we have to put either it minus or plus here. So we look at the direction of loop at the center of the circuit. So loop 1 coming down, going down, and loop 2 also going down, same direction here, so we put plus. Okay, and then we simplify the equation, so here we get negative 5. Here we get 300 I1 plus 200 I3. So this would be our second equation based on KVL. Okay. And for loop 2, as I said just now, loop 2 represents the current that flows on the right wing of the circuit. So here its label has I3, so this is loop I3. Using the same argument, total EMF equals to total voltage drops. So our EMF here, we have 9 volt and 15 volt around the loop. So for 9 volt, the direction is same with the loop, so we should put it positive 9. And for 15 volt is against the loop, opposite direction, the supply and the loop, so we should negative 50. And then we can see here there are two resistors around the loop, 200 and 300. So 200 plus 300, I3, and 200 in the middle, so 200 times I1. So here we have plus sign because same direction of loop. So this is, and then we can simplify this equation to negative 6 equals to 500 I3 plus 200 I1 to make it similar to the second equation, 200 I1 plus 500 I3. So this is equation 3. Now we have to do the simultaneous equation to solve this unknown equation to get I1 and I3. So we want to cancel out the I1. So we take equation 2, we times with 2. 2 times 2. Okay, so we get here negative 10 equals to 600 from 2, and from equation 3 we times with 3. So 6 times 3, 5. And from here we can eliminate I1, I1 by we do the subtraction of equation 4 to 5, 4 minus 5. So we have here negative 10 minus 18. So we get here positive 8, and this is negative 1100 I3. Therefore I3 equals to 8 divided by 100, 1100. So 8 divided by 1100. So we get I3 as negative 7.273 milliampere. Okay, so we have milli prefix symbol here, so we have milliampere here. And now we let me continue over here. Continue over here. So substitute I3 equals to negative 7.273 milliamp into we can choose any equation 2, 3, 4, 5 here. So let's say we choose equation number 2. So we have here negative 5 equals to 300 I1 plus 200 times I3 is negative 7.273 milli. And so we have here, so from here, here, and now we have 200 times negative 7.273 shift milli. Okay, so this is, and so for I1, so I1 is equals to negative 5. This one we put there, so plus 1.4546 divide with 300. So negative 5 plus 1.4546 divide with 300. So we have I1 as negative 11.818 milliampere. Okay. So actually from here we have complete until step number 3. Where here we have the we solve the KCL equation. This is the actually step number 3. Solve KVL. Okay. And now for the last step, we solve KCL. Okay, so we refer from equation 1. So now we have I1 and I3, so we want to get I2 equals to I1 plus I3. So with I1 11.818 milli, I3 is negative 7.273 milli. So now we can calculate it. Negative 11.818 shift minus 7.273 shift. So you may get the answer as negative 19.091 milliampere. So now we get all those three unknowns current, where I1 is negative 11.818, I2 is negative 19.091 milliampere, and I3 is negative 7.273 milliampere. Okay. So negative here means that the direction that have been labeled on this question is opposite from the actual direction. So I1 positively, in actual situation, it should be moving out from this node. I2 will be coming in, and I3 should be moving out from this node. So that's why we get all the answer in negative sign. Actually, it's just opposite of the direction of current that have been determined from the circuit. So I think that's all for this example. Hope you enjoy watching this video, and I hope it could increase your understanding on solve circuit problem using Kirchhoff law. Thank you.